Hello, I want to continue discussion of logic programming with a very famous old uh, project called Strips. The point of this is to create directions for what a robot should do, moving around a world that we describe logically. This is the world that we are looking at. I've drawn the picture of the world, and over here I've drawn the initial state. We have as predicates ATR, which is where the robot is, and AT, which is a binary predicate, which is where a different item is. So the boxes, box 1 is in room such and such. A, B, C, and D represent a room. Now, with this, we want to instruct the robot somehow to move all 3 boxes into one room. Expressing that in terms of the logic is we want there to exist an X, such that at box 1X and at box 2X and at box 3X. We have 2 operators that we can use. Each operator has what's called a precondition and a delete list and a add list and a negated precondition. Now, we can push an object K from room M to room N. The precondition is that we have the robot and the object in the same room, the room M. And when we do this, we delete that the robot is in room M. We add that the robot is in room N, and we delete that the box is in room M, and we add that it is in room N. The other thing the robot can do is go to from one room to another. The precondition here is that the robot's in the first room, and he's going to go to the second room, so we delete where he is and add where he's going. Now that particular item is taken directly from the paper, and the description up there is more or less also taken directly from the paper, which I will post on Strips. So how in the world do we do this? Well, remember, we have this set of conditions. So let's copy these conditions and put them down as the first things that we have in our proof. So I guess what I'll say is these are the first things we can do. And I'll give them numbers to make it easier for us to refer to them. So this is 1, and this is 2, and this is 3, and this is 4. Now the next thing we always have to do is put in the negative of the conclusion. So here is the conclusion, and we have to place the negative of it in here. So 5, I want the negative of the conclusion. I didn't copy it, sorry. Try that again. Control C, and bring it down to here. Put it right there. All right. Now the negative of that, what we want is the negative of that. And what that means is we have to take the negative past the there exists. But if it's not true that there exists an x, then for all x, not. So we would first move this to for all x. It is not true that we have this item here. Pardon me. And I better put some parentheses in that I left out, like one there. And I'll put one here, pardon me, and one here. And my guess is I left out a parentheses up above. And I want to do that, so let me put that in too. Now, we're almost there, but we can't have negatives stand outside of ands and ors. So we use the De Morgan law as usual. We take this item, we place it here, and I'm going to drop the for all because it's a universal. What I do is I take the negative into here, I switch this to an and, I put a negative here, I switch this to an and, put a negative here, negative, pardon me, and again, it looks like I have a few more things to do. I don't really care where the robot is, so I don't know why this was carried around. I'm going to drop this, and that probably explains why I have a problem with the parentheses. So there's my answer. There's number 5. All right, how are we going to attack this? Well, the way he does it is to look at the preconditions and see what we can do. But I'm going to do it by resolution. I'm going to say, for example, look at the at our D. We would like to apply the push, but we need to get the robot into some place. So we want the robot to move to one of these places. Now, I have a box in B, so I'm going to move the robot to B. So I will go to, the robot will go from, oh, wait a minute, the robot's in D, isn't he? Leave him there. That's fine. No, it isn't. I have to get the boxes. So go to, from where you are in D to B. Now it says up here that if I do a go to, the precondition that is that he's in the first room, so that's D, and I delete the ATRM and I add the ATRN. So delete 1 and add ATRB. So now I have the robot in a different room. Now, what's my next step? Well, let's see. The robot can push an object from K from place M to place N as long as the robot is in the same place. Well, I'm going to push box 1 from B to D. It says here I can do that. That's the way it's described. Push an item from one to another. I have the robot in the same box, the same place that box 1 is. So to do that, I go up here and say, I have to remove where the robot is, remove where the box is, and change that. So delete at box 1 at box 1 in B, and at the robot in B, and add at box 1 in D, and at robot in D. Well, now I've gotten 2 of the boxes together. So my next chore is to get the last box. So I'm going to go to, I am in D, I have to go to C to pick up box 3. So I am deleting 3, and I'm deleting at robot D, and I'm adding at robot. Oh, pardon me, I can't delete 3 yet. The only thing I can delete is where the robot is. So I'm deleting that, and I'm putting the robot in C. Now I have the conditions I need to push the robot again, to have the push again. So I push the box through 2 from room C to room D. And that means that I delete ATRC, okay, and at robot C, and add at robot D, and at box 3, box 2, pardon me, in D. Well, it looks to me like I now have all 3 boxes in D. Now, I can clash let's see if I can get that to remain C. I can clash at box 1D and at box 2D and at box 3D with 5, where I substitute for D for X. I have a contradiction because I have nothing left, and I have shown I can do the requested item. Now, I could have done that with some clashing, but I thought that might be better to do it this way. We, again, can look at it and see what we want to do. But the robot or the automatic theorem prover would have to go step by step and would inevitably go down some wrong paths. But that's the way life is. So this is an application of the logic that we are looking at. And it was a nice project. It's very old, but it was a very nice project to show what could be done in this particular case. So that's what I want to show you. I will put this out in a few minutes. I will also post the STRIPS program, the STRIPS paper, and I will post this file. So long now.